Hi, it's Quang, and I'm doing a video for assignment 1, which is weighted directed graphs. So start off by using the demo code that was given by the teacher, contain the vertex class in a directed graph class. I also add a variable called number of edges to track the total number of edges. Move on, I finished the contains functions. It wasn't hard, just fine. If there's the vertex in the all vertices list, check if the graph contains the vertex. Therefore, adjacent, if basically just check if there's an edge between the vertex um, to the destination. So if there's an edge found, then the source vertex is adjacent to the destination vertex. For add vertex, add edge, remove vertex, and remove edge. Those are basic functions, so I believe um, that everyone can do it. Just a little bit different here in the add edge. I increment the total number of edge by 1, and when I remove the edge, I decrement the total number of edge by 1. So I can keep track of the total number of edges. For the in degree and out degree, I create like a variable called count to track the total number of edges coming from the vertex. So step 2, check if the graph contains the vertex, iterate to the edge list which contain all the edges. If there's an outcoming edge from the vertex, uh, then increment the count by 1. Then return the count to the function. For the degree, also with the in degree, it's the same thing. Just check if there's incoming edge um, from all edge to from the from if there's any incoming edge to the vertex. Sorry. For the degree, just return the total number of in degree and out degree. Number of vertices, to get the total number of vertices, return the all vertices size. Num edge, return number of edges. Get vertices, create a vector called v, and then this v gonna contain all the vertex in the vertices list. For get neighbors, um, get neighbors is basically contain vector called v, and then this v will push back any um, vertex that is found as adjacent to the source vertex. That's it. So return v. For get second order neighbor, it took me 1 to 2 days to finish it. It was kind of hard, but even though I got the code to work, the output was wrong, was incorrect. Move on, reachable function took me 1 to 2 days to finish. With the reachable function, I also create another function called has visited. It's down the bottom. So had visited basically check whether in the vector contain the item or not. If the item is in the vector, then return true. Move on the contain cycles. It's basically just call reachable again and again in the edge list. So if the source ID is reachable with itself, then graph contains cycle. Um, these are the functions that I didn't finish. I understand the concept of them, but I couldn't write it down to the code. It was too hard for me, I think. Sorry for that. For significance sorting, I just do um, I just use selection sort. First, I got a vector called V. I get all the vertices. Then I think weight with its followers can tell the popularity of nodes. Then after all this sorting done, I return V, and I think that's it. That's the end of my video. Thank you for listening. That's all the challenges I face. It's kind of hard to get these done, so I didn't get full mark. I get 8 out of 12, but I'm satisfied.